Okay, just going to walk you through the section test. Number 1, 1 over 2x minus 1. I see that as a bracket on the bottom, so it's a half. You bring it up, it's minus a half. Integrate a bracket, derivative must be in front. The derivative of that is 2, so you balance outside with a half. Then your derivative disappears. You add 1 to the power, divide by it. Don't forget your c. The halves cancel out, giving you 2x minus 1 plus c. Number 2 is another bracket one. So it's 1, 2, 3x minus 1 cubed. Derivative of the brackets is 3. Balance outside. Add 1 to the bracket. Remember the derivative disappears. 2, 1. So just sub in your 2 and sub in your 1. Number 3. Integrate e5x dx. It's an e function, so you must have the derivative in front. Derivative is 5, balance outside with a fifth. When it goes away, derivative disappears. Number 4, we've got limits on here. So it's 3x minus 1. It's an x function on the bottom. So it's going to be one of these log ones. Derivative must be on top. So I need that to be a 3. Balance outside by a third. Once you've that done, you log the bottom line and put in the 2 and the 1. So sub in 2, then sub in 1 and subtract the 2. Number 5, integrate sine a half x dx. Okay, where did sine come from? If you differentiate cos, it goes to minus sine. So it has to be a minus in front, so balance outside. You must have the derivative in front, and you balance outside with a 2, because that will make it turn back to a 1. So when you're integrating, you go back to the cos, the derivative disappears, and don't forget your c. Number 6. You have here x squared over 1 minus x cubed squared. Well, that's a bracket on the bottom. So bring it up the minus. Derivative of the bracket, if you differentiate this, you get minus 3x squared. I've got the x squared, but I need the minus 3. And balance outside with 1 over minus 3. So it's minus a third. When you integrate a bracket, you add 1 to the power and divide by it. So tidying that up, 2 minuses is a plus. So it's 1 over 3. And this can pop in the bottom row again. And don't forget your c. Number 7, it's on your page. Integral of e to the minus 3x over 1 minus e to the minus 3x. It's a log one, because you've got an x function in the bottom. I need the derivative of that. Again, if you're not happy doing the derivative in your head, go over to the side. Derivative of that disappears and you differentiate it. Differentiating an e function. The derivative of this, which is minus 3, goes in front. And then you write the e function down as it is. 2 minuses cancel off. Okay, so that's what my derivative is. That's what I want in the top line. So I need to pop a 3 in and balance outside. Now I can integrate. So you log the bottom line and it's a plus c. Number 8. This is one of these special cases I talked about before. I'm not sure what exercise it was in, but what I'm going to do is I'm going to write this with the sign in front, and I'm going to treat my cos as a bracket. To integrate a bracket, you must have the derivative in front. Remember, cos goes to a minus sign, so do your balancing. Now I've got the derivative in front, you can integrate. So add 1 to the bracket, divide by it, and it's a plus c. And just write that as minus cos to the power 4x. That's how you write that nice and neatly. Number 9, ex minus e minus x squared dx. but I don't have the derivative of that in front. And remember, you can't balance with x's, so there's only one way of doing this, and that is to square out this. You can either do the quick way, which is square the first, square the last, and double the product. Or you could write out ex minus e minus x, write the bracket out twice, and just times out the long way. Doesn't matter, you get the same answer either way. Power to power means multiply. Power to power means multiply. Multiplying two numbers, you add the powers, so that's e to the 0. If you decided to times them out, you have ex times ax, add the powers. You have minus ex to e to the minus x, add the powers, then times through that one. So it's minus e to the minus x, e to the x, so e0, and then do the last two, plus e to the minus x, e to the minus x, which is add the powers, e to the minus 2x, so you get the same expression. I would split that all up and do separate integrals for each. And remember that e to the 0 is just a 1. So how do you integrate an e? You must have the derivative in front. Derivative, that's a 2, balance outside. When you integrate it back, the derivative disappears. The derivative is a minus 2. I must have it in front, so I balance outside with 1 over minus 2. Outside, I now have a positive half. When you integrate that, the derivative disappears. Integrate that, it becomes an x, and you're left with plus c. Okay, last one, number 10. So we get 0 to 1 x squared add 1 dx. So it's a log type one. The derivative of the bottom is 2x. I needed 2 up here, so pop your 2 in and balance outside. So now I can log the bottom line. This one's got limits, so it's 1 and 0. So you just sub in your 1 and sub in your 0. Remember, log 1 is 0, so that gives you half log 2.